Hello students, I am Marco Severo. This is the Marketing Analytics course. We are in part 4 of Working with Data and Descriptive Statistics. We are in the practical activities of the course, working with data using the Gretl software. More specifically, in this lecture, we are going to discuss dispersion measures and why they're important. There are 3 important measures of dispersion in statistics, and we are going to see how they are applied in marketing analytics environment. These measures are variance, standard deviation, and coefficient of variation. After that, and after analyzing data using this framework and trying to uncover why dispersion is important to marketing, we are going to put everything together in a famous graphic of statistics, which is the box plot. The first definition, the first measure of dispersion we are going to understand is variance. And variance usually is not in the same scale as the variable under study because we square the variable to analyze its dispersion. Consequently, variance usually inflates nominal values, and we have to resort to a mathematical operation such as the square root to go back to the usual actual value of the variable. So standard deviation is more reliable and is more used than variance, while variance is only a route to reach to standard deviation as a measure. Another important measure of dispersion is the coefficient of variation, and it is important because it allows me to compare different coefficients of variations of variables that aren't in the same scale. Coefficient of variation usually is calculated using 100 times the standard deviation of the variable divided by its mean. So if we go back in the last lecture, I presented to you the first moment of statistics, which was the mean, and using the mean I can reach to dispersion measures such as variance and standard deviation and then coefficient of variation. So this is quite simple, the basic definition, but the important thing to marketing managers is to analyze how these dispersion measures behave in practice, okay? So let's reproduce that in the software that we are using in this course, which is Gretl. So I'm going to open Gretl. And we are going to work with the Hollywood movies dataset again, but only the Big 6 studios dataset. So I'm going to File, Open Data, and then go to User File, and I'm going to find the dataset in my computer. If you are having a look in this video, I'm going to put available the dataset in the description of this video, okay? So I have the Big 6 only data. I'm going to open this dataset. But I'm also going to open a text file that I generated like 2-3 lectures ago. I don't know if you remember, the ones who are following this from the beginning, this course from the beginning, if you remember the categories for the string variables. More specifically, we're going to work with this variable today, which is movie genres, okay? Different movie genres. So I have action, animation, adventure, thriller, and etc. So I'm going to let this open because this is going to be important for us. So the first thing I'm going to do with the software, I want to have an idea about the descriptive statistics of 2 quantitative variables, which are the domestic gross revenue from movies and the world gross revenues from movies. So first thing I'm going to do, I'm going to generate the summary statistics from for the for the domestic gross, and I'm going to do it again with the world gross revenue. And the first thing we are going to note is that obviously the mean of world gross revenue is quite higher than the domestic gross revenue, but look how funny it is. The standard deviation of this variable is lower than the mean when we are talking about domestic gross revenue. Consequently, the coefficient of variation is lower than 1, which means that the mean is quite higher than the standard deviation, and for the world gross revenue it's the opposite. So standard deviation is quite higher than the mean, and this have an important implication for the coefficient of variation and also for the skewness, okay, for the symmetry. Let's see how this behaves in practice. I'm going to generate the graphic of the distribution of these both variables, okay? So of the domestic gross revenue, I right click with my mouse and frequency distribution and click on OK. So quite a symmetry. But remember that in this case, the mean is higher than the standard deviation. I'm going to do this again with the world gross revenue, frequency distribution, and then OK. Now we see some patterns that maybe suggest why this variable it's more variable than domestic gross revenue. We observe this value right here, which is a movie that generated a lot of revenue, and it is quite the difference quite higher from these observations, which is not the case of the distance from this one to this ones. So this is conceptually defined as an outlier. We're going to see that in the box plot in the future, okay, in the next minutes. So basically I have an idea of the relationship of between them, okay. We're going to follow with the analysis. Let me close this. What we are going to do now, we are going to analyze how audience score behaves conditioned on the movie genre. I'm going to double click with here, and then we're going to see lots of movies, and unfortunately for some of them I don't have any information about the genre, the style of the movie. So I'm going to close here, go to sample, and then you click on drop observations with missing values and click on OK. So I just had dropped 162 observations. If I have a look here, we are observing that I'm working with a reduced sample of my Big 6 movies dataset, which are the movies that I have the entire information about this variable, which is the movie style, movie genre, okay? Okay, that is right. The first thing I want to do now is have an idea about the central tendency and dispersion measures of audience score conditioned on the movie genre. What we are going to do, you click on the model, and then you go to other linear models, and then you click on ANOVA, and then you select audience score as the response variable, and then the movie genre as the treatment variable, and click on OK. I'm not going to analyze this now, but please have a look here. So these levels are exactly these levels coded by the software. So for action movies inside a data set, the average audience score is 0.62 and the standard deviation is 16. For animation, for example, the average audience score is 71, which is quite expected, right? So animation deals with more children, and they are more attached to movies, and probably they are inclined to give better reviews and better evaluations about movies, and the standard deviation is also lower. So I can analyze this condition on this variable condition on the movie styles and movie genre. The higher variation of the audience score is number 4, which is thrillers, and the lowest average score for movie genre is number 14, which is mystery. Okay, mystery movies. So probably the market is smaller, and it's difficult to everyone. It's difficult to everyone feel satisfied with the movie. What I'm going to do now, I'm going to generate a figure which is classified in statistics as box plot, and we're going to analyze the dispersion and central tendency measures of some movies styles. So this variable, we have lots of levels. I'm going to reduce the sample just for exposition purposes. Okay, we are going to work with from movies from classified as action to comedy. Okay, so I'm going to restrict the sample again using these 5 movie genres. So I'm going to click here and go to sample, restrict based on criterion. I'm going to let this selected add to current restriction because I'm going to restrict again. I'm going to select gen. So if gen is smaller than 6, and I'm going to click on OK. Oh, sorry. Let me remove this if. Okay, I just drop another 89 observations, and I'm now working with action, adventure. I'm working with this action, animation, adventure, thriller, and comedy. So the first thing I'm going to do, I'm going to generate again that basic statistics. We're going to model other linear models and then ANOVA. The response variable will be audience score, and the treatment variable will be again genre. And I have a quite idea about the behavior of this, but it's not a visual idea. And to understand the visual idea, I want you to go to View, Graph, the specific vars, which is variables in this case. We're going to click on Factorize Box Plot, and then click on Audience Score, which is the variable to plot, and then Genre, which will be the factor variable. I'm going to click on OK, and now I have different box plots for the movie styles, which are action, animation, adventure, thriller, and comedy. How can I interpret this graphic? So I'm going to analyze this one. So imagine this as the distribution. Okay, so this is the interquartile range, and this is the median value. Right here is the median value. And this plus sign is the mean value. Traditionally, box plots don't present the mean values, but Gretl present them. And this is the left side of the distribution and the right side of the distribution. And with this graph, comparing with different movie genres, I can conclude lots of things. So, for example, I can conclude that this movie style, varies less than this one because the values are more restricted. And additionally, they are better evaluated than this if we analyze median and mean values. So we see this here, this is the median value right here, and this is the mean value. If we analyze a symmetry, probably this distribution is more asymmetric than others. This is because this left part of the distribution, which is concentrated the lower audience score values, it is quite higher than this, the right part, where are concentrated the higher audience score values. Comparing with action, for example, we observe that the left part is almost the same size as the right part. So the box plot is important because you can analyze the entire shape of the distribution without actually seeing the shape. And if we understand the fundamentals behind box plot, which are where is the median, what the left wing, what the left part and the right part means, we can understand and compare applying to marketing performance and to marketing measures. In this case, is very important because audience score signalizes an important satisfaction variable regarding different movie styles and movie genres. So, thank you very much.